you can build all the models you want, but if you don't understand your end user, the one who's going to interface with the model, then you're not going to build things that are useful for them.
Hello, everyone. Welcome to the Data Scientist Show. Today, we have Andrew Kondrich. He's an ML engineer at scale, working on interactive AI systems, spanning applications from data annotation to business intelligence in enterprise. Previously, he studied computer science at Stanford and conducted research on robotics, crowdsourcing, and machine learning with Professor Fei-Fei Li and Andrew Ng. He thinks a lot about human-first design for AI, computer systems, and how to build great ML teams. Welcome, Andrew.
Thank you for having me.
You studied computer science at Stanford, interned in Apple. Can you tell us more about your career journey?
Sure. So I actually only really got started with computer science in college, but my exposure to a lot of the research and professors at Stanford really motivated me to learn more and dive deeply into the field. I would say my career really with AI started my sophomore year when I joined Andrew Ng's lab at Stanford. We were working on problems in healthcare, particularly looking at electronic health records and trying to predict certain risk. So doing a risk assessment using large-scale databases of health records. That experience really was motivating for me to learn more about AI, to dive into lots of different types of data modalities going forward, like computer vision and other problems. So that really was the beginning of my career in AI. After that, I worked on a number of projects, climate change related. Then I moved into Fei-Fei's lab my junior year, my third year of college, where I started working with robotics and imitation learning, crowdsourcing specifically.
Mm-hmm. Yeah, definitely want to ask you more later about what was it like doing research with Andrew Ng and Fei-Fei Li, and also in robotics. So right now you work at Scale. Can you tell us what's your day-to-day like at Scale, and what does Scale do?
Yeah, so I would categorize Scale as having two main focuses within the company. One is around data annotation, which is our historically largest product. And then more recently, we've focused a lot on AI infrastructure projects. And I've worked on both of these categories of product in my time at Scale. On the data annotation side, I've worked on 2D semantic segmentation for our self-driving customers. Particularly what we're trying to solve as machine learning engineers at Scale is a problem around operational efficiency and quality. So we have large crowdsourced taskers, labelers, right? So who are every day processing these scenes, and we want to use machine learning to expedite that process. Particularly what we're trying to do is to let the computer do the basic visual processing tasks, the things that are pretty repetitive, menial, right? Not necessarily needs human understanding. Mm-hmm. And then enabling the human to then do the semantic reasoning. So understand how to fit this particular scene into the specification given by the customer. So dividing that labor between the human and the machine learning model is a fascinating area of research. And we're thinking about this day to day in our role as machine learning engineers.
I see. So what type of tools do you use? What are the core skills and responsibilities for a machine learning research engineer role at Scale?
Yeah, great question. So Scale is unique in the amount of labeled complex data that we have access to across all of our customers, right? So really the main tools that we're using are deep learning models, particularly. We want to train these models that can comprehend image data or point cloud data or natural language and somehow enable the labeler to finish the task quicker with higher quality. So the tools, yeah, essentially the toolkit is basic, like deep learning tools like PyTorch. We use PyTorch all the time internally. And we're also deploying these models at scale. right? So we have thousands of annotators, and we need to be able to analyze the data with which they're working on quickly and efficiently in real time. So Kubernetes is another big tool that we're using under the hood to power that inference, scalable inference.
Training the deep learning models, a lot of machine learning practitioners these days, they struggle with a lack of data. And I think this is probably not a problem for you because you're working on data labeling. What are some challenges for you currently as a machine learning research engineer?
Yeah, it is a great point. And in fact, we perhaps suffer from the other problem, which is we have such a diversity of data, right? Each customer, even if they're all perhaps doing self-driving, they're testing in different areas. They have different camera setups, and accommodating these changes and taxonomies, right? So they have different ways that in which they want to classify the world for the perception task, right? So generalizing models across all of these different specs, right, that our customers provide for us is actually quite a challenging task. That's probably the biggest problem we're trying to face today.
Mm-hmm.
Another really interesting thing here is our models are human in the loop, right? So we want to deploy these models into the data labeling process. And then we also want to measure the downstream impact of this model. So we've actually seen in the past that certain models, once we deploy them into the system, they actually decrease quality, or they decrease the efficiency of the human labeler. And to feed that back into model design is another one of our biggest challenges that we face day to day.
Yeah, I think that's very important. You mentioned that because a lot of times we're thinking, oh, machine learning is cool. We want to automate everything. We want to build a machine learning model, but sometimes maybe that solution is not the most efficient one. So how do you make sure you use machine learning model will actually improve the efficiency? And then if it doesn't, do you just abandon a machine learning approach, or what would you do?
Yeah, great question. We had to build a lot of infrastructure around A/B testing and measuring the impact of our model. And it's actually hard to even quantify sometimes the downstream metric that we want to optimize, whether it's quality, right? Quality is a very abstract concept. There's no single metric, quantitative way to put a number to quality. So really it comes down to a lot of auditing, right? Qualitative stuff. We even have interviewed our labelers in the past to ask them how the tools are working for them. And we use that very low level feedback, right? Just that word of mouth feedback to further improve our model. So it's a great point because we don't really have a way to predict how good our model is going to be. We have to just test, and we do a lot of iterative testing and modeling to get to a point where we see that our model is helping.
Yeah, I think it's great that you are working from the beginning of the machine learning pipeline all the way to the end. You're talking to the customers, the users. I think a lot of scientists, when they just started working at the industry, they're just focusing on building models, thinking about accuracy, but not so much about who is going to use the model, what is the impact.
Yeah, absolutely. I completely agree. I think like that operations around machine learning is really important for the ML engineer or scientist to understand as well.
And for someone just started in machine learning, what type of advice do you have for them?
So I think it's very important to understand the fundamentals that are underlying everything we do today. So the choice of model, whether it's a transformer or like convolutional neural network, right? All these designs, they come and go. But at the end of the day, we're all trying to solve some very basic problems around like statistical modeling, understanding systems that are too hard to measure, too hard to quantify in just the equation. And thinking at that very fundamental level about like, what is the abstractions at which we want to build machine learning models at is very important. So, and that will go you the longest way. So really, you know, if you're a university student, like take those basic machine learning theory classes, and those will actually be the ones that are most useful down the line.
And if someone wants to do similar type of works like what you're doing right now, what type of skill set do you need?
So right now, our problems are largely deep learning based. However, I think there is one more level of skills that I would personally be looking for in this kind of role, and that is like a product mindset. So we're not just ML engineers. We're not really doing research like academic research, right? It's not like you can build a model and be done with it. You really have to think about that end goal business metric that you're trying to optimize,
Right.
and care deeply about that goal, because that should be the thing that is governing your design choices, not necessarily trying to use the most recent or cool model.
Yeah, I love it. And if someone is new to product mindset or working with a business, how can I acquire this skill or practice this type of thinking?
Well, you should just join Scale or some, get that startup experience under your belt. I Before joining Scale, I didn't even really understand that this is like a problem you could have, right? Most of my experience is in large industry labs or in an academic setting where you're not really thinking about product, but just being forced to think about that, right? Being forced to, you're given a business metric as a goal, and then you need to understand how you actually optimize on that. I think that's the best way to learn how to do this.
Yeah. And besides developing the mindset to think like a product manager or business owner, what are some other things that you only learned after you started working in the industry, but you didn't realize in school?
Yeah, so a lot of the technical system design was something I learned a lot on the job at Scale, right? So to go into the details, like Kubernetes, right? Like that was a tool that you don't really get exposure to perhaps in school. And it's a very core part of our workflow. And even like AWS services, right? So understanding how S3 works, understanding how EC2 Lambda functions, right? Like all of these kind of distributed system design components are very fundamental to how technology companies run today. So that was something I had to learn a lot on the job.
Yeah. And if someone tell you, hey, I become a machine learning researcher because I'm just want to spend a lot of time on my algorithms. I just want to do the math, train a model. Is there some type of role for this type of interests?
Yeah, I mean, I think a PhD is a great place to explore like that academic interest, obviously. Industry labs, bigger companies, right? Bigger companies that can afford just having people thinking in a very exploratory manner to just mess around with algorithms. It's probably a great place for that. But I think we've seen more and more kind of in a recent trend that everyone's thinking about data, right? Everyone wants to be, everyone's realizing that even if you tune your algorithm, at the end of the day, your performance is going to be bottlenecked by the quality of the data.
Yeah.
And solving that operational problem around data quality is an interesting topic, and it's something that everybody cares about.
Yeah. And I think everybody has different preferences in the different area in the machine learning, right? Someone is more interested in infrastructure. Someone might be more interested in the modeling. But if you really want to deliver a project, I think whether it's in academia or in the industry, you have to have the mindset of taking ownership from the beginning to the end. So talking about data, why is data labeling so important for machine learning?
Yeah, that's a great question. I mean, obviously, I think a lot of the current, what we know works with deep learning is supervised learning, right? With annotations, data annotations. And I think if you are a company and you are trying to use machine learning in some part of your operational pipeline or as part of a product, you don't really want to be taking like big bets with the implementation of your algorithm, right? Like you want to deliver a result. And I think Scale AI does a great job around helping companies deliver results, right? We can annotate your data. We provide that infrastructure around your model and deliver to you that end goal business result that you want to pursue. So data labeling is kind of tried and true in a lot of ways, and it's very flexible, right? So I think Scale has solved that problem of like being flexible in terms of the customer's needs. So I think that's generally my answer, right? Like, so it's tried and true. We know how to do it well, and there's a lot of tools around operationalizing and productionizing your models.
Yeah, that's pretty cool. And previously, you mentioned you're interested in human-first design for AI, and obviously, right now you are working on a lot of human-in-the-loop problem. Can you tell us what is human-first design?
Yeah, so I think broadly, what we see at Scale is you can build all the models you want, but if you don't understand your end user, the one who's going to interface with the model, then you're not going to build things that are useful for them. And I think this is kind of an interesting paradigm flip, because most academics don't really think about this, right? They kind of build models that optimize a benchmark, right? Like you want to perform on ImageNet and you just chase that benchmark. But in the real world, you have a much more qualitative, fuzzy description of your goal. And that usually it comes from like some end human user. So when I think about like human first design, it is, you're not pursuing a benchmark score, like a number, you're pursuing like having a good experience for your human user. And designing your models that accommodate for that is actually quite challenging and perhaps a paradigm shift in the way of thinking.
Yeah. And so now if you want to hire someone for your team, how do you ask questions to figure out whether a candidate have this type of quality, or you think this is something you can help develop once you hire them?
Yeah, I think a lot of it comes with just learning the business context that you operate in. Our interview process is very well-rounded, I would say. We try to understand whether the candidate is product first, right? Understanding if they have this mindset around owning the design and deployment of the model end to end. But yeah, I think really what we're just looking for is potential perhaps, but you really need to learn these skills on the job, I think, and think actually interacts with the users. There's really is no like theoretical or abstract way to pick up these skills, in my opinion.
Yeah. And what are the most important quality you're looking for? For example, if someone who doesn't have a master or PhD, can they still become a machine learning research engineer?
Yeah, absolutely. It all comes down to just having that previous experience building models. I think we're not chasing credentials. We're just chasing like this mindset that ML engineers have. And it's kind of like a if you know, you know type of scenario, like around thinking around model design, knowing what the latest interesting problems are and models in the space. And if you just show that interest and that passion and that know-how, right, around what is working, what doesn't, and you have some implementation experience, right? Like we can drop you into our code base and you could instantly start recognizing like, oh, this is something I've worked with before. This training code I've used in the past, like understanding just how these patterns work around machine learning design and development. I think that's really the core competency we're seeking.
Yeah, so I hear that relevant machine learning experience, someone worked on an end-to-end project working on deploying a model in production, and also the demonstration of passion and interest. They're two very important factors.
Yeah, like if you're keeping up with latest research, you read arXiv, right? You know how to read a research paper. That's like the core skill.
Yeah.
Things that come with having a master's and a PhD. So if you have one of those qualifications, we assume you've read papers and you've implemented papers. But of course, obviously, we're not chasing the qualification itself.
Yeah. And how do you build great ML teams?
I think one thing I've learned at scale around building like a ML team, like understanding how to operate as an ML team, is having that ability to understand the context in which you operate and having really great intra-team communication. So at scale, our ML team is kind of standalone. We're not directly embedded in our product teams, but we've seen that if you understand how to communicate with your product teams really well, and you have connections and you have relationships and friends and coworkers in those teams, then those are the ML people that perform the best. So I really think like an ML team is a lot like a design team where you have to really understand the context, the users and the fellow technical developers on the project to do well. So it's like a very general context that makes an ML team great.
Yeah, communication is very important. And I love that you mentioned you don't just make friends with other machine learning researchers, you also make friends with the product managers, understand their language, their goals. So when you work with product managers or with your stakeholders, customers, have you ever had experience that sometimes they give you some mission impossible? They want you to deliver, I don't know, 100% accuracy or something like that. But it was difficult for you to do. How do you handle those type of situations?
Yeah, I think that goes back to like building like communication point, as I mentioned before, right? Like the product manager will understand the limitations and the things that you can build. And a lot of times at scale, we see that we might have a new hypothesis for a model design, and it's completely different than things we've done in the past. And it also requires engineering effort from a product team, right? So it's not just a thing that ML can develop on its own. It requires responsibility and ownership across teams. And in these scenarios, if you have really clear communication and set the objective really well, right? You're very smart around setting, here's the metric exactly that we want to optimize, and we think we can optimize by this %. And then you go to the product manager and you say, hey, we want to propose this kind of design. I think that most of my experience have been more like that. I think the scale product managers are also very ML competent. They understand machine learning and they understand what's possible and what's not. So I've had a great relationship on that front with product people and understanding those expectations.
Yeah, that's great. And so what are some mistakes you have made in your career?
Yeah, that is also a great question. I think I'm preaching about like user-driven design and like understanding product teams because at the beginning when I joined Scale, I didn't do this, right? I was very of the mindset like I just want to build the biggest model possible and just scale and compute will solve all of our problems for us. So this was like hopelessly naive looking back. I spent a few months in a direction that in the end I just scrapped and changed to this like operational mindset, thinking from the product first. So exactly the mistakes that I've been talking about earlier, right? Like thinking just about the algorithm are mistakes I've made. So yeah, that's really it.
Yeah, thanks for sharing that. I think a lot of us, when we started working, we can't wait to put what we learn in school in our work, and often too obsessed with the model instead of solving the business problem. What do you think of the future of machine learning or machine learning infrastructure?
So I think machine learning is really powerful when you have good subject matter expertise. Currently, this is realized by either having the machine learning engineer also be a subject matter expert by just learning what's actually happening, or having really good communication with those SMEs. But I think the future really should be that the SMEs should be able to develop their own models. And having that basic level of, I guess, understanding of machine learning as well as giving them the tools to quickly iterate, design, build models is it would be the future of machine learning. Like there is this push towards no code, low code, right?
Yeah.
For website design and kind of other software development. I think a similar push in machine learning would be a great idea. And I think Scale is kind of working towards that today as well.
Right. So you're thinking subject matter experts can maybe have a tool like Excel. You can just drag and drop and then build a machine learning model or maybe a simple prototype. And do you think those type of tools will replace data scientists?
I think those tools are kind of inherently opinionated, and you won't be able to build things that are fully custom or perhaps production ready.
Yeah.
At least that's kind of what I've seen as a trend in the no code direction. So data scientists will definitely fill that really custom hole kind of in that process. And I think also like it frees up data scientists perhaps to think about even higher level problems, right? Like where can we deploy machine learning at a company level scale, not necessarily within these like product verticals to just abstractly generalize things, right? Like platform teams, like a great platform team is one that you don't even realize exists, right? You just log in the next day and you see like a 10% performance improvement in your like build times because the platform team optimized that, right? So like living at that level of abstraction would be interesting for machine learning teams going forward.
Yeah. And with the help of no code, low code tools, what are some type of skills you think data scientists or machine learning engineers can develop so they can stay competitive in say 5 or 10 years? What are something that cannot be replaced by tools?
Yeah, I mean, I don't think tools will ever replace engineers. I mean, we still have software engineers today, right?
Yeah.
And I honestly don't think this is a problem because you always want to be pushing the frontier of what's possible with machine learning. Like the ML engineers should be working on that kind of innovative front, and that innovative front may inherently not be solvable with kind of low code tools, perhaps. So that's kind of my take. Like research, innovation, right? Pushing the boundaries of what's possible with machine learning is always something machine learning engineers can be working on. And even this said, like there are existing low code tools for ML, but I don't really know how much traction they've gained. So perhaps I'm mistaken on my like characterization of that, but it's just a hypothesis.
Yeah. And you mentioned you want to hire someone who is able to read a paper and kind of create a model based on the paper, keep kind of stay updated with the most recent research. So there are a lot of new papers, new models out every day. How do you keep yourself updated to the most recent research?
Yeah, I think it's more like a question of understanding what are the big trends, right? Instead of necessarily going out and implementing the most recent paper. Honestly, if you're even like a few months behind, that's probably the best place to be because you can see what ideas were presented a few months ago and then still are popular today. Those are probably the ones we're thinking about. I mean, an obvious one here is probably like transformers, like from a few years ago. Like nowadays, there are a lot of interesting work around self-supervision, right? So kind of just following those trends perhaps and thinking about them at abstract level and understanding how they fit into the rest of the context of the machine learning field. That's probably the kind of a good way to think about it.
Yeah. And what are some website or events for people to get updated from the industry?
So if you want to get a really kind of great update from a live update with keynote speakers, Scale is actually hosting a conference called Transform X soon. It has like Professor Fei Li and Andrew Ng and Eric Schmidt, Ilya Sutskever will all be presenting. So if you want to get that up-to-date view, definitely attend the Transform X conference.
You have Dr. Feifei Li and Andrew Ng. So what was it like to work with them in research labs?
It was good. It was great. I learned a lot from, I think Andrew and Feifei are very high level, right? They are thinking at this, what are the paradigm shifts happening in AI?
Yeah.
Feifei particularly, she's interested in embodied cognition, right? So the idea that ML will move away from this static inference that we have with deep learning and towards like interactive agents. And I think that general trend is particularly fascinating. And Andrew is thinking about like very high level applications of ML and like this idea that there is so much out there today that just doesn't take advantage of machine learning. And that's like those industries, those applications we need to be going after. Like, I think both of these theses as to like ML are very fascinating. I learned a lot about the just daily operational development stuff from PhD students and other masters and undergrad students in those labs. So it's very collaborative.
Yeah, that's great. So there are a lot of new research and new models, and a lot of data science or machine learning research feel overwhelmed, or some people just feel they have imposter syndrome because they can't stay updated to everything. What are some advice you have for them? Like, what is the most important thing when learning about the new models, new research?
Yeah, I think the best thing to do is just like find a niche, right? And really dig into it. When I was in my undergrad, I was very interested in robotics, and I was following all the latest research coming out of robotics and machine learning, like that intersection, right? And there relatively isn't, that flood of papers that we see in machine learning. Really comes down to a manageable amount that you can read in a week, in a day, even from that intersection, right? So this was in my experience working at the intersection of robotics, imitation learning, machine learning. And nowadays it's similar for me, right? So I'm interested in machine learning systems, human AI interaction, like design, like system design for machine learning. And similarly, I have a niche in which I can stay focused. So I think that's my biggest point of advice, is like find that niche. And if you are sufficiently specialized, you can actually very quickly become an expert even in a particular topic.
Yeah, that's a great advice. And what got you interested in computer science and machine learning when you were in high school or when you were a teenager?
Yeah, so I actually wasn't that much. I wasn't exposed to machine learning or computer science in high school or as a teenager. It was really only something I learned in college. But again, I think the thing that really drove me to get interested in is how much, like, particularly the concentration of smart people working on machine learning that I had the opportunity to work with, and just learning from them and being inspired by their career path and attempting to follow it was kind of the thing that really drove me into this field.
Well, you said you weren't super interested in machine learning or computer science when you were a teenager, and then what were you like when you were a teenager?
I don't know. I liked. I thought I would study economics. I like thinking about. I was definitely more of a perhaps social science guy, right? Like I really enjoyed history, and I still do to this day really enjoy history. I like thinking about, I guess, in an academic setting, thinking about like bigger trends and just societal trends as well.
What are some trends that some bold prediction you have about the future?
That's a great one. Frankly, I'm not. I can't say any of my predictions are particularly bold. I don't really think there's anything like contrarian, so to speak. I mean, I think that technology is very, like, the future of technology is particularly fascinating. Understanding how machine learning can be used for good versus kind of nefarious purposes. I think that's a fascinating trend, right? Like, we've seen machine learning is really enabled by those actors that can really get large amounts of data, right? And now we have all these issues about like civil liberties, data privacy, that is also very intricately tied to machine learning development. So trying to shape this moral landscape, right, around how we build our models in the face of data privacy and just generally like surveillance, I think it is quite fascinating.
And for books about machine learning and AI, do you have a favorite one that you want to recommend for our listeners?
I can't necessarily like I actually did most of my learning from like course notes, particularly through my undergrad. And there's a lot of really good content online from Stanford. Like you could find the CS229 notes online, the 231N notes.
Yeah.
So that's Fei-Fei's like 231N, CS231N. That's Fei-Fei's class on convolutional networks, but it's really such a great foundation around machine learning. It was actually written by Andre Karpathy originally, right? So he wrote these notes when he was a PhD student. And these notes, like these course notes are good because they're written in like a common language, right? There's no kind of pretentiousness around it, perhaps. It's just very straightforward, great visuals. They aim to just get you to understand intuitively these concepts. So
yeah,
course notes, I highly recommend.
Yeah, great. Thanks for sharing that. And now you work in a startup. Besides building models, you also have business goals you try to meet. So sometimes I can imagine it might get a little stressful if something doesn't work or there's a bug. How do you handle those stressful situations?
Yeah, I think it comes down to just being prepared, perhaps. I think the stress is, at least in my experience, stress only happens when like you perhaps there's a chance you'll under deliver, right, in the near future. And I really think if you're just have a really rigorous schedule around running experiments, and you have some understanding of like the trend in your, at least like if you're building a machine learning model, right, perhaps you have some level of impact you want to achieve on the business metric. If you just have like a very rigorous schedule around that iterative development process that I was talking about earlier, like consistently improving step by step, just making those incremental changes, they add up, and sometimes they even compound, right? So a small change today can lead to a much bigger change tomorrow. So
right.
I think the stress alleviates itself in the long run if you're very regimented and you have like consistent performance, like on average, right? So it's even if you have some good days, bad days, your model did worse for some reason, as long as you're making that steady march upwards, I think that's fine. And I think people at scale understand this as well, right? Like you can have an entire bad quarter, right? Because you just can get a model to work well. But if you can show that progress over time, then that's kind of the thing everyone cares about the most.
Yeah. So what is your career goals? What are some ambitions you have?
Yeah, great question. So at Scale, I've been also working a lot on this second avenue of product around like AI infrastructure, and just generally helping companies that don't have ML expertise or don't even have any perhaps discipline around their data, to let them get to that point where they can productionize machine learning. And this has been really, really, really fascinating to me. And I like working this direction, right? So getting data AI ready, and even if it's not structured in a way that machine learning can use it, still somehow build that data ingestion processing pipeline and deploy those models for our customers. I think that's a really fascinating next step. I think that I'll be working on in for a while. We just started this direction around, it's almost like a consulting role where we're working with companies to help them understand their data needs and getting their data AI ready.
Yeah, that is very exciting. So before we wrap up, what are some other things in your career or in your life that you are very excited about?
Well, I'm excited to return to the office. we are potentially moving back in to a in-person office
Nice.
come October.
Mhm.
So just getting more FaceTime with my peers and my friends is the thing I'm really looking forward to. Hopefully things will keep going, progressing like well in this direction.
Yeah. And so thank you so much for sharing your career journey and your experience working at Scale. If people want to know more about your career research, want to get in touch, what's the best way for them to find you?
Please connect with me on LinkedIn. I'm happy to chat. I guess you can share a link or something.
Yeah.
My profile, you can find my profile, Andrew Kondrich on LinkedIn, and follow me on Twitter. And I am happy to chat over Twitter as well.
Awesome. Are you hiring right now?
The team is hiring. Yeah, the team's hiring. We're in a pretty big recruiting push right now. So I'm not personally hiring, but the company is looking for machine learning engineers and software engineers to work on these hard problems in AI and AI infrastructure.
Mm-hmm. Awesome. I will put them in the notes. Again, thank you, Andrew, for joining me in the Data Scientist Show, and look forward to seeing your next steps and what Scale is building in the next few months.
Yeah, thank you for having me. I've really enjoyed this.